Let's talk about the limiting reagent, also known as the limiting reactant. So get a notebook, pause the video, and then try to write out the definition of the limiting reagent, or just pay attention attentively. But I would advise each time you're watching a video, you get a book and then write down and try to attempt some of the questions. Okay, so what is a limiting reagent? So a limiting reagent is basically a reactant that finishes faster in a chemical reaction. Okay, so we can also define the limiting reagent to be a reactant that produces less of a product. Okay, so we can look at the reaction that we have. If we're having a reaction between hydrogen and nitrogen, the one that is going to finish faster is what we call the limiting reagent. Okay, so why do we call it the limiting reagent? We call it the limiting reagent because it is the one that is basically limiting how much of the product is produced. Okay, so think of you having let's say sugar, right? Let's say we have 1 kg of sugar or even 2 kg, and then you just have like a cup of water. So a cup of water that you have is going to limit the amount of the glucose or vesicle that you're going to make. Okay, so that is what we're calling the limiting reagent. It is going to limit how much you can make. That's what we are saying. So equally, when you look at this reaction, whatever is going to finish faster between the two reactants is what we are calling the limiting reagent. The other one is called the excess because it is what is left over after a reaction. So if I ask you to define an excess reagent, it is the reagent or the reactant that remains unused or unfinished at the end of a chemical reaction. The limiting reagent, on the other hand, finishes completely while the other one remains. Okay, so now that we know what a limiting reagent is and what an excess reagent is, we can now move on to understand basically what we are trying to say. So let's try to assume we have 2 moles of hydrogen and then 2 moles of nitrogen in a reaction. Which one is the excess and which one is limiting? So we'll try to determine first of all. So each time you're trying to determine the limiting reagent, it is very important that you get to determine the number of moles. In this example, I'm using moles, but in most of the cases, they are going to give you, let's say they give you 20 grams of both hydrogen and nitrogen are reacting. So now it is up to you to use the 20 grams and then get the hydrogen, which is H2, ignore the coefficients, and then find the number of moles of each. And then you try to make a decision from there. Okay, so now the basic idea is you don't get to determine the limiting reagent by looking at the one having the least number of moles. No, that's not the way it works. So I'll get the hydrogen and compare it against our product. Okay, so we can say that if we compare our hydrogen to our ammonia which is being produced, they are in the ratio of 3 to 2. So I'll try to get the number of moles of my hydrogen. I'll put it there, and then I'll try to find how many moles of the ammonia are going to be produced. So if we cross and multiply there, we're going to have 3x being equal to a 4. So our value of x is going to be 4 divided by 3, which is the 1.33. So those are the number of moles of our ammonia that are going to be produced. Do the same. Compare now the other reactant, which is nitrogen. Nitrogen against the ammonia. These guys are in the ratio of 1 to 2. And then we now have 2 moles. How many do we expect to produce? So if you cross and multiply, your x is directly going to be equal to a 4. So 2 moles of nitrogen are producing 4 moles of that. and then 2 moles of the hydrogen are producing 1.33 moles. So which one is producing more? So the nitrogen is producing more moles, and then the hydrogen is producing lesser moles. So the one that is producing less is what we call the limiting reagent. Okay. So in the actual sense, if we get to react 2 moles of hydrogen and 2 moles of nitrogen, what is going to be produced is what? In case a question asks you to say how much is going to be produced, how many moles of ammonia are going to be produced, we always go for the limiting one. Okay. So in this case, the answer would be 1.33 moles of ammonia are going to be produced. Okay. So that implies that despite us having the nitrogen which is capable of producing a lot of moles, it is not going to entirely react because there is not enough of the other reactant. I think that is the simplest explanation I can give. So there can be questions arising to say, determine the number of moles of the excess reagent that had reacted, all those questions. So in that regard, you'd have to compare the reactants. So the limiting reagent has been determined to be hydrogen. So use the hydrogen, compare it against the other reactant, which is nitrogen. Now you realize that these guys are in the ratio of 3 to 1, right? So 3 to 1. So how many moles of hydrogen did we have? 2 moles. Determine the number of moles of the nitrogen that were in excess. So if you get to cross and multiply there, you're going to have 3x being equal to 2, and then 2 divided by 3, so we have 0.67. So 0.67 are the number of moles of nitrogen that had reacted. So x is representing the number of moles of nitrogen that had reacted with 2 moles of hydrogen. So what this means is, when you get to react 2 moles of nitrogen and hydrogen, the 2 moles of hydrogen is going to finish by only reacting with a 0.67. So meaning that the two from the 2 moles of nitrogen available, only 0.67 is going to be used. And that's why we are saying from there the products will stop being formed, because the other reactant has been depleted. So that's why we use what finishes to predict the amount of the products and not what is excess, because in the actual sense not the entire 2 moles of nitrogen are going to take part in the reaction. So if we get to subtract what had reacted by using the limiting reagent, and we subtract from what was available, that gives us now what was in excess. So that's what was in excess. 1.33 moles of our nitrogen was in excess. Now I want you to look at this question and try to attempt it. Calculate the mass of magnesium oxide if possible. Not if possible. Calculate the mass of magnesium oxide possible if 2.40 grams of magnesium reacts with 10 grams of oxygen. So it's very necessary, very important, each time you have a reaction, make sure you balance the equation. So make sure if you've given you an equation, make sure you observe what is there. So we have 1 magnesium on the left, we have 1 on the right as well. Oxygen, we have got 1 on the left, we have 2. So we can put a 2 there to balance the oxygen atoms, and then we'd have to put a 2 again on the magnesium to balance the number of magnesium atoms, and we've balanced the equation now. Okay, so what do we say? We need to find the mass of magnesium oxide that is going to be produced in this reaction. So we've been given to say oxygen is 10 grams, magnesium is 2.40 grams according to the question. So if you've not done yet so, feel free to pause and then try to find the mass. Okay, so if you look at this question, what exactly are you able to see? You are capable of finding the number of moles, right? It's possible for you to find the number of moles of both magnesium and oxygen. So now, do well to check your periodic table. check your periodic table and basically see the molar mass of both magnesium and oxygen. So of course oxygen we know it's 15.994, and then what do we know about magnesium? Magnesium is 24.31. Okay, so basically go by that. So we can determine the number of moles of magnesium. Number of moles of magnesium is going to be given as a mass over its molar mass. So the mass is 2.40 grams, and then we'll try by the number of molar mass. We are dividing by the molar mass, which is 24.31. So 24.31 grams per mole. So what are you going to get there? 2.40 divided by 24.31. So approximately I'm getting 0.0987 moles. So we have a number of moles of magnesium. Now we can also find the number of moles of oxygen. So equally we'll do the same. The mass of oxygen was given to be 10 grams. Now we'll have to divide by the molar mass. Now each time you are determining the number of moles, whenever you have something the atomic or having a subscript, it is considered in determining the relative molecular mass. So, but we don't consider the coefficients. We ignore the coefficients as seen in magnesium, but we are considering the subscripts. If we add a 3 on magnesium, we'll do the same, but in this case, we have only a coefficient. We don't consider the coefficients of the mole ratios. So we'd have to multiply by 2. So the 2 multiplied by the 15.994 over oxygen, which approximately will be 31.988, which is just like 32 grams per mole. So I get to divide that. So our number of moles over oxygen, 0.3126 moles of our diatomic oxygen with a subscript 2. So now, which one is limiting in between the two? Is it oxygen or magnesium? Which one is the limiting reagent? So we've calculated the number of moles, right? We've calculated the number of moles. So we can try to use the number of moles and determine how many moles are to be produced. Okay. So let's assume this question was general, where they had asked us to say find the limiting reagent. In that case, we'll look at what we have. So let me just try to move this one here so that we can work with it. Okay, can move it there. Okay, so we have our oxygen there. These are a number of moles of our oxygen. So we know these guys are in the ratio of 2 to 1, right? So of course I've swapped them. This is magnesium. So magnesium has got a stoichiometric coefficient of a 2. Oxygen has got a stoichiometric coefficient of a 1. So if you get to divide them into their values, what do you expect to have? So on this side of oxygen, the number of moles remain the same. And then on the magnesium part, 0.0987 divided by 2. So that would be 0.04935. So which one is bigger? So the one that is bigger is in excess, the one that is smaller is limiting. So we can clearly see that the number of moles of magnesium after dividing by the mole ratios is actually smaller. So in this case we can conclude to say it's a limiting reagent. That is the shortcut in terms of determining which one is the limiting reagent. Okay. So you now know how to determine the limiting reagent by using the mole ratios and the number of moles. Now in this case, we know that since we found our limiting reagent, we're supposed to use our limiting reagent to determine the product. So use the mole ratios. Now in this case, we'll assume we've not found the limiting reagent. We're just going direct. So we can do it by two ways. First of all, we'll consider the same magnesium. So magnesium compared to our magnesium oxide, these two guys are in the ratio of they're in the ratio of 2 to 2, which implies that they're in the ratio of 1 to 1. So magnesium compared to magnesium oxide, they are in the ratio of 2 to 2, which is just like 1 to 1. So when two reactants products or a reactant and a product are in the ratio of 1 to 1, it tells us to say that they have got the same number of moles. So the number of moles that we've determined of magnesium are exactly the number of moles of magnesium oxide that can be expected. So therefore, the same number of magnesium that we have for the number of moles is the same number of moles of magnesium oxide. So therefore, we have the number of moles of magnesium oxide already. And then you know how to find the mass, right? We know the number of moles is mass over molar mass. So you can find the mass as a product of the number of moles and the molar mass. So how do you find the molar mass? We have, of course, I said ignore the stoichiometric coefficient. So our magnesium is 24.31. And then plus oxygen, which is 15.994, right? So our answer for the molar mass is approximately 40.3. So our mass is obviously going to be a product of the number of moles and the molar mass. So I'll go direct. I'll multiply the two. The molar mass I've told you to say, I've found 40.304. The units are grams per mole. So multiply directly number of moles times molar mass to give you the mass. So our mass, which is the product of the number of moles and molar mass, will give us 0.0987 multiplied by our molar mass. The mass is 3.978 grams. Okay, so what's the mass if we are to use magnesium? Now let's try to consider oxygen. In this case, we are assuming we didn't know what was limiting. So equally for oxygen, compare oxygen against magnesium oxide. These guys are in the ratio of what? So oxygen, there's a coefficient of a 1. For magnesium oxide, there's a 2. So we are in the ratio of 1 to 2. So if we have 0.3126, how many moles of magnesium oxide do we expect? I've put X to represent that. So in this case, they are supposed to be doubled. So the number of moles would be 0.6252. So using those number of moles, you can multiply them against the molar mass as well. So after multiplying by the molar mass against the number of moles that are expected by using oxygen, the expected mass is 25.198 grams, which is like wrong. Okay, so we can't use oxygen because it is going to give us what is not true. It was in excess. Not every amount of oxygen reacted in the reaction, because our limiting reagent was our magnesium, as earlier predicted by the mole ratios. So always whenever we want you to determine the amount of a product that was produced, we get to use the limiting reagent. The limiting reagent concept is very, very necessary and very important in the study of stoichiometry and our chemistry in general. So just some quick few points that you would need to get is in this case, if the question had asked us to determine how much of the oxygen was left over after the reaction, in that case, knowing that we've determined our magnesium to be limiting, we can use the mole ratios between magnesium and our oxygen to determine how many moles of oxygen are basically reacted in the actual reaction. So you find that these guys are in the ratio of 2 to 1. So now that magnesium is limiting, we can get this number of moles to use it to determine the number of moles of oxygen that actually reacted. So the value of X that you're going to get represents the number of moles of oxygen that reacted. And then this is what is reacted. Now notice that in the question they've also given you the mass of oxygen, which we had used to find the number of moles. So that number of moles of oxygen that you can find using 10 grams is what was available. So subtract from what was available, remove how much had reacted. It gives you the number of moles that were left over or in excess. So you can use the number of moles that were in excess and the relative molecular mass of your oxygen molecule to find the mass that was left over after the reaction. So thank you very much for watching, and do have a lovely day. I hope you enjoyed the video.